Arizona Science is supported by Research Corporation for Science Advancement.
For AZPM, I'm Leslie Tolbert, Regents Professor Emerita in Neuroscience at the University of Arizona, and this is Arizona Science. Our guest today is Sara Moran, a postdoctoral fellow in UA's Lunar and Planetary Laboratory. Sara will be giving the third talk in the 2024 College of Science Public Lecture Series this year. Her title is Strange New Worlds, Steamy Planets, Crystal Clouds, and the Seeds of Life. Thanks for coming to give us a preview of your talk, Sara.
Thanks very much for having me.
The theme of this year's public lecture series is surprise twists that transformed science. What's the gist of the story you're going to present?
So first, the idea of exoplanets themselves are kind of a twist. We sort of expected that there could be other planets beyond the solar system, but the ones we found immediately surprised us.
Are you able to distinguish different kinds of planets, rocky planets, gaseous planets, in your research?
Absolutely. So that's one of the sort of first things we learn when we go and find a planet. So we can figure out its size and how much mass it has. And if we have those two things together, we can figure out if it's more likely to be rocky or if it's more likely to be gas. One of the most common types of planets that we see are these very large rocky planets that we call super-Earths. We also see things that are about the size of Earth, and it turns out they're extremely common. We haven't yet been able to characterize most of them in any amount of detail, but we know that there are tons of them out there.
You're looking at planets that revolve around other suns. Do all of these planets revolve around suns? And are there limits to the number of planets that you find revolving around a sun?
Most of the planets that we can characterize are around other suns, but we do occasionally find what we call rogue planets, which are, we think maybe they formed in a star system and they had a sun and then they somehow got ejected and now they're just floating kind of lonely in space. It's possible that they formed through some other mechanism and they're just always been kind of there and lonely, but most of the ones we know about and can characterize are around other suns.
And how many of these planets are you tracking at any given time?
So we just crossed a pretty major threshold in the number of known exoplanets. The number was 5,500 that we know about, but that's that we know exist, not the ones that we can look in detail at and characterize and learn things about their atmospheres. That's more on the order of dozens. So we have maybe 50 planets that we can get to know in all of their glory.
And so how different do they look across each other as well as from the planets that we know revolving around our sun?
So that's one of the major questions in the field is how different can planets be? We end up with these huge temperature ranges, and so that right away changes things. But there's a kind of planet we call super-Earths and mini-Neptunes, which are named that way because they're between the size of Earth and Neptune in our own solar system. But we don't have an example of that in our solar system. And so that's a really big question is, are they something that's sort of a mixture of the two? Are they totally different? Some people think that they're what we would call water worlds, where they're mostly made up of water. But we haven't actually measured that to know it for sure. And so that's an outstanding thing people are really working on right now, is trying to figure out.
How would you determine whether there's water?
So we go and measure it with a space telescope or potentially with a ground-based telescope. So we look with Hubble or with the James Webb Space Telescope, and we try to measure distinct wavelengths of light where water absorbs. And so if we can see that water there, that's a good hint to us that we know it exists. If we can measure multiple bands of water, we can maybe figure out how much water is in the system. And then that can start to tell us, is this a water world? Is this more like Neptune that's mostly gas with just a thin amount of water there? And try to put those pieces together to understand what these planets are like.
Does your research change the way you think about our Earth?
Absolutely. I've always been interested in climate change and caring about environmentalism, but really putting it into perspective of how unique we certainly are at the moment has made me care much more about protecting Earth as it is, and maybe not letting it evolve into some of these extreme states that we've observed in other planets. I also have a better appreciation for the physics and chemistry that goes into even just a weather report on the radio. And so that's been another kind of fun aspect of my work.
Well, thank you very much, Sara. This has been a wonderful introduction to your talk. It sounds like it'll be really fascinating. Dr. Sara Moran is an expert in planets beyond our own solar system, and especially in their planetary atmospheres. You can listen to this and all Arizona Science conversations at azpm.org/Arizona Science. I'm Leslie Tolbert.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.